All right, ladies and gentlemen, today we're going to talk about how do we solve square root functions as well as cube root functions. Okay, so before we get into the actual solving of this, there's one little idea that we have to talk about, and it is the extraneous solutions. If you notice, the word extraneous has the word extra in it, and that's what you can think about when we talk about extraneous solutions. It's an answer you get when you solve equations that might not really be an answer. It's like an extra answer that really doesn't work. Okay? And this usually happens when, while you're solving, you raise both sides of the equation to an even power. And when we're dealing today, the type of equations that we're dealing with, sometimes this raising of both sides of an equation to an even power will happen. Okay? So let's get into these examples. Here's the steps we're going to follow. What I will tell you is, as we do some of these examples, we're going to follow these steps, but some of these examples end up having previous skills of solving equations. Like, for example, in problem A, we're going to eventually have to factor to solve, as you will see. But we'll do our best, and we're going to follow these steps here as we go along, okay? So let's start off with example A. First thing we're going to do is we want to take any fractional exponents or rational exponents and turn them back into radicals. If you notice in example A, we don't have exponents that are fractions, but we already have a square root, okay? So step one is kind of already done for us. The next thing we want to do is we want to isolate the radical. That means we want to get this square root guy all by himself, and all the stuff inside, we want it to stay on one side of the equation by itself. Everything else has to move on the other. So to help us do that, I'm going to put a little line here so we can designate this as the left side of the equation. Here's the right side of the equation. So as we look, the square root is not isolated. We have to get rid of things outside the square root to the other side. So we have a positive 2 here. To get rid of something that's positive 2 to the other side, we are simply going to subtract 2 to both sides. Okay, we now have this. X plus 10 still equal to, and on the right side we have x minus 2. Okay, our square root stuff is now isolated. We have a square root all by itself on one side of the equal sign. Step 2 is complete. Now we want to remove the radical, and depending on what type of root we have, right now we have a root of 2 or a square root. To get rid of the root of 2, we are going to square both sides. So remember, powers of 2 get rid of roots of 2. But what you do to one side, you do to the other. So I'm going to raise this entire thing to the power of 2. And what I do to one side, I'm going to do to everything on the other. And what happens is we have now simply removed the radical, or canceled the radical. So now I have x plus 10 equal to x minus 2 to the second. Now this turns into a problem that we should know how to solve, okay? So our goal is to solve for x. To solve for x, which is step 4, I'm going to have to do some math here. So what the first thing you should notice is I need to raise this to the power of 2. And it doesn't mean distribute. What we're actually doing is this. Okay? And so before I actually do more math, the new stuff that I'm supposed to teach you it's already done. We did the hard part for this lesson, which is basically get rid of the square root to solve. This part we're about to do, this section on, is pretty much stuff we've talked about. It's basically we're about to solve a quadratic. So this work I'm about to do, yes, it's part of my answer here, but this is a previous skill that you learned in Im2 and also a little bit in Im3. So just follow along, see if you remember what's going on. Okay, so I got to clean this up. I'm going to distribute. That's going to give me x squared minus 2x, and then we'll distribute here. That's minus 2x plus 4. Combine like terms, we get minus 4x plus 4, all still equal to x plus 10. Okay, like I said earlier, we're going to have a quadratic, a power of 2 here. So that means we got to set this guy equal to 0. So I don't want to move this x squared to the left because it makes it negative. You want to keep the x squared guy positive, so I'm going to move both of these guys to the right. And we'll do it by subtracting x. What you do to one side, do to the other. The negative x goes there. And now we have 10 equal to x squared minus 5x plus 4. And then again, I'm going to subtract 10 because we want it equal to 0. So we now have 0 equal to x squared minus 5x minus 6. Okay, let's continue this problem up here. So I'll just kind of rewrite it a little bit nicer. X squared minus 5x minus 6 equal to 0. And to solve a quadratic, yes, it's coming back, we have to factor. So we're going to use the diamond method. The AC value, A times C goes here. If you remember this, the B value goes here. And to do all that, A times C is 1 times negative 6, so negative 6 is here. Let's clean this up a little bit better. Negative 6, and then the B value is the middle guy here, negative 5. So what multiplies to the top guy, negative 6, that adds up to negative 5, and that should be fairly simple. It's negative 6 times positive 1. So if you recall, to factor, we're going to rewrite using the splitting of the B method. So we have x squared. The negative 5 have been split into 6 and 1. So it's negative 6x plus 1x minus 6 equals 0. And then we factor by grouping. Hopefully this is all coming back to you. So I'm going to factor out of x. This is x minus 6. Here I'm going to factor out a 1, a positive 1, and this is going to be x minus 6. And to finish factor by grouping, we regroup. The GCFs go in one, the common parentheses go in another. So it's going to be x plus 1, x minus 6, all equal to 0. And now we can set each factor equal to 0 and solve. Okay, subtract 1, x is equal to negative 1, add 6 to both sides, x is equal to 6. So these are my solutions. But now, if you look at step 5, we have to plug this back into the original, and we're going to check for extraneous solutions or extra answers that do not work to the original equation. So let's kind of do this here. I'm going to erase this stuff, and I'm going to plug this stuff back into here. All right, so all this work is going away. Hopefully you can rewind it to see that work again. But now what I'm going to do is we're going to plug in x into the x spot. So we're going to do negative 1 first. And we are checking for extraneous solutions. So we have 2 plus negative 1 plus 10 equal to negative 1. So let's do the math. Order of operations says we kind of do this first because it's like parentheses. So it's 2 plus the square root of negative 1 plus 10 equal to negative 1. So it's 2 plus the square root of 9 equal to negative 1. The square root of 9 is 3. So 2 plus 3 equal to negative 1. And 2 plus 3, that is actually 5. And 5 is not equal to negative 1. So we can now say that x equal to negative 1 is an extraneous solution. All right? But just because we found 1, we got to check does 6 even work? So we're going to do the same thing for 6. We're going to take our answer x equal to 6 and plug it in. So let's try this. All right. Let's do this. So we have 2 plus radical, and then we have 6 plus 10 equal to 6. Square root of 16 equal to 6. Okay, square root of 16 is 4, so it's 2 plus 4 is equal to, oops, I made a little mistake here. This is 6. So 2 plus square root of 16 is 4 equal to 6. 2 plus 4 is 6. 6 is equal to 6. This is true. It checks off. So this is our correct solution. X is the correct. X equal to 6 is the solution. X equal to negative 1 is extraneous. All right. Let's do one more example. Okay. So we are going to solve B. Again, following these steps. We're going to rewrite as radicals. So these fractional exponents I've had here, we're going to convert these into radicals. So if you do this correctly, it looks like this. As plus 6 square root, because 1/2 means square root. And then we have the square root of 2x minus 4, all equal to 0. Okay? So rewrite as radicals, we're done. We're now going to isolate the radicals. And what you should notice, again, to isolate, we want to get a radical all by itself on one side of the equal sign. So we have the left side of the equal sign, we have the right side of the equal sign. All we want to do, even though there's two radicals, we just want one of them by themselves on the left side. As long as one of them's by themselves, I don't care what's on the other side. So, in essence, I really just want to get this guy by himself. Okay? So, which means I have to get rid of this radical. Even though it's another radical, we still can move it to the other side. So, this radical here is subtracting. To move anything that's subtracting to the other side of the equal sign, we're going to just simply add it to the other side. So we're going to add 2x minus radical 2x minus 4, and what you do to one side, you do to the other. These cancel out, and we're left with radical or square root x plus 6 equal to square root 2x minus 4. Again, step 2 is done because we isolated the radical. Even though they're both isolated, as long as one is isolated, we have done step 2. Okay? So looking at this radical, because this is the one we tried to isolate, since it's all by itself, we can move on to step 3. We want to remove the radical by either squaring both sides, if I have a square root. If I have a cube root, we would raise it to the power of 3. So since we have a square root, I'm going to square both sides. And what you do to one side, do to the other. So when this happens, what happens really nicely is the power of 2 and the square root cancel out on both guys, and we're just left with the inside stuff. So x plus 6 equals 2x minus 4, and this turns into a simple algebra 1 problem. All I have to do is solve for x. So I'm going to subtract 2x to solve for x, get the x's together. That's going to give me negative x plus 6 equal to negative 4, minus 6, because we want to isolate the x now. And that's going to give me negative x equals to negative 10. And then we are going to take negative x equal to negative 10, and we are going to divide by negative 1 to get rid of that negative sign. Cancels, x is equal to positive 10. Okay, now let's just check if this is extraneous or an actual solution. So we solve for x. Now we're going to plug back into the original to check if it's extraneous. So let me erase all this work again. Again, if you need it, you could always rewind the video to see the work again. And what we're going to do is we're going to plug in x back into the original, okay? But I like to do it with the radicals. It just makes my life easier. So I'm going to rewrite it as radical form. So we're going to have this x plus 6 minus radical 2x minus 4. But instead of x, I'm going to plug in 10. So it's radical, all this should equal to 0 if it's a correct solution. So it's 10 plus 6 minus radical 2 times 10 minus 4. And let's do this math. So 10 plus 6 is radical 16 minus, this is going to give me 20 minus 4, square root of 16 minus the radical 16. Square root of 16 is 4. Square root of this 16 is also 4. 4 minus 4, if you do this correctly, it does equal 0. And everything works out. So this is a solution. All right. Let's do one more example for good luck. Let's go ahead and jump over to example D. All right, again, I have the steps here for you. So let's work this example D out. All right, we want to rewrite the radicals if we had fractional exponents. So we don't, so I'm going to leave it like this. Next, isolate the radical. Notice we have a cube root. I want to get the cube root by itself. So I'm going to subtract 7 from both sides. Get the radical isolated. So I now have x plus 2 cube root equal to negative 2. All right, the radical is isolated. We're going to remove the radical by either square rooting if it's a square, or squaring or raising to the power 2 if it's a square root, or cubing both sides if it's a cube root. Since we have a 3 here, that means it's a cube root, which means we have to cube both sides or raise it to the power of 3. Remember, powers get rid of roots as long as the powers match. And what we do to one side, do to the other. The cube and the cube root eliminate, and we're left with the inside of the radical, x plus 2. Negative 2 to the third power, that's really negative 2 times negative 2 times negative 2, which would give me negative 8. And now we can solve step 4, solve for x. Subtract 2, and x is equal to negative 10. Now we just got to check. Is this a solution or is it extraneous? So let's take x equal to negative 10 and plug it into our original problem. So we have 10, negative 10 plus 2 plus 7 equal to 5. So negative 10 plus 2, so the cube root of negative 8 plus 7 on the outside equals 5. And the cube root of negative 8, if you throw that in your calculator, it actually gives you negative 2. Or in other words, what number multiplied so to itself 3 times gives you negative 8, and that answer is negative 2. Negative 2 plus 7. And negative 2 plus 7 is 5, which equals 5. And this is a true statement. Therefore, this is a correct solution. All right. That concludes the notes for today.